October 23, 2022, 11 p.m., Cebu, Philippines. Korean Air Flight 631. 173 people. A 24-year-old Airbus A330. 3 approaches in a thunderstorm. The right main gear hit a concrete step 6 inches high. 6 inches. That single impact killed the normal brakes, the anti-skid, the thrust reversers, the ground spoilers. 5 independent systems gone in 1 second. The only thing left was the emergency brake. The pilots pressed the pedals. They got 10 seconds of pressure. Then the pedals went dead. 83 knots. 173 people. Nothing left to stop them. Inside the hydraulic system, a valve had been leaking for years. No maintenance check ever looked for it. No one knew it could fail this way. How does a modern airliner lose every single way to stop? That question would take investigators more than 2 years to answer. And what they found was not a single catastrophic failure, but a chain of small, reasonable, perfectly logical events that should never have been able to combine. A 15-centimeter edge that no one repaired, a valve that leaked where no one could see, a safety system that worked exactly as designed, and still could not save them. Each piece made perfect sense on its own. Together, they created something that the engineers who built this aircraft believed was impossible. This is the story of Korean Air Flight 631, and it begins on a routine Sunday evening at Seoul Incheon International Airport, where a crew of 11 was preparing to fly 162 passengers to the Philippine island of Cebu. The captain was 52 years old, with roughly 13,000 flying hours, more than 9,000 of them on the A330. He had spent most of his career on this aircraft. He knew its systems, its handling, its quirks in turbulence. His first officer was 37, significantly less experienced, with around 1,600 total hours, a little over 1,000 on the A330. Still, the majority of his flying had also been on this type. They were joined by 9 cabin crew for the 4-hour flight south. Before departure, the crew reviewed the dispatch paperwork and technical log. The aircraft, registration Hotel Lima 7525, was a 24-year-old A330 that had been with Korean Air since delivery in 1998. It was originally scheduled for retirement by the end of that year. The tech log showed no significant faults. Everything appeared normal. Deep inside the aircraft's hydraulic system, a small device called the pressure release valve sat inside the park hydraulic manifold, doing something it was never supposed to do. It was leaking, 0.5 liter per minute, hydraulic fluid escaping from the service side back into the return line. The damage to its internal spring was old. Nobody knew when it had happened. Nobody knew it was happening now. And because the fluid never left the system, simply cycling back into the reservoir, there was no external sign. No puddle on the tarmac, no low fluid warning, no indication at all. The one effect the leak did have was subtle. The brake accumulators, which store hydraulic pressure to hold the parking brake after the engines shut down, lost their pressure faster than normal on this aircraft. But since accumulator pressure always bleeds away overnight, and since ground crews always placed wheel chocks before leaving, nobody measured the rate of decline. If the pressure was low in the morning, the procedure was simply to start the hydraulic pumps and recharge. There was no requirement to report it, no reason to investigate. The weather briefing showed thunderstorm cells moving towards Cebu around the time of their scheduled arrival after 10 p.m. local time. The ILS for the runway was out of service, so the crew planned for an RNAV approach. They loaded extra fuel to account for possible holding or a diversion. Standard preparation for stormy weather, nothing unusual. In the cabin, 162 passengers settled into their seats for the 4-hour flight. Families, tourists heading for Cebu's beaches and resorts, business travelers connecting through to the southern Philippines. Overhead bins clicked shut, seat belts buckled, the doors closed on 173 souls in all. Outside, the Korean Air livery gleamed under the terminal lights. Inside the hydraulic manifold, the PRV leaked on. It had leaked through the previous flight, and the one before that, and every flight before that going back months or years. It would leak through this flight too. The only question was whether anything would ever make that leak matter. At approximately 18:05 Philippine time, Flight 631 lined up and took off from Seoul Incheon, with the captain as pilot flying and the first officer monitoring. The climb and cruise were uneventful, the aircraft droning south through the night sky, over the East China Sea and the Philippine archipelago. 4 hours of calm before the storm. As the aircraft began its descent towards Cebu, the weather picture started shifting. The wind initially favored runway 04, so the crew set up and briefed for that approach. But as they descended further, air traffic control reported that the wind had shifted. Thunderstorm cells were reshaping the local conditions. The active runway was now 22, the reciprocal direction. The crew agreed to switch. It meant rebriefing the approach, but landing with a tailwind in a thunderstorm was a worse option. They accepted vectors for the RNAV approach to runway 22 and soon intercepted the inbound course. Despite the darkness and the weather, the crew acquired the runway visually well before their decision height. The captain continued the approach. But then, at very low altitude, a heavy rain shower swept across the field directly in front of them, wiping out the runway completely. The captain reacted immediately and executed a go-around. It was flown cleanly, exactly by the book. The crew ran the checklist, briefed the cabin, and accepted vectors for a second attempt. This is exactly what extra fuel is for. Storm cells move. Sometimes you just need to wait. Flight 631 intercepted the approach a second time and began descending toward runway 22. But the weather was not cooperating. Another cell was approaching, and now, below 500 feet, the turbulence hit. To understand what happened next, you need to know how a pilot manages the final seconds before touchdown. Below 500 feet, the aircraft must be stabilized, configured for landing, on speed, on path. Only minor corrections needed. When turbulence and gusty winds push the aircraft off the glide path, the instinct is to chase it. Pitch up to regain the path. Pitch down when you overshoot. But the airplane responds slowly. The corrections arrive after the gust has already changed. The inputs fall out of phase with the turbulence. The aircraft oscillates above and below the path, and each correction makes the next one worse. The captain disconnected the autopilot at around 300 feet. Immediately, a gust pushed them below the path. He pitched up. The gust subsided and the aircraft rose above the path. He pushed forward to correct. The descent rate jumped to 1,000 feet per minute, more than what you want that close to the ground. At 150 feet, he pitched up again to stop the sink. But at that exact moment, the wind shifted from crosswind to tailwind, accompanied by a downdraft of roughly 500 feet per minute. His pitch-up input was no longer enough. The first officer saw it on the instruments. The numbers were going the wrong way. He called out what he was trained to call: sink rate, go around. But they were below 75 feet. There was not enough air left beneath them to climb away without first touching the ground. If the go-around had been initiated 1 second earlier, everything that followed would never have happened. 1 second. That was the margin. As the engines accelerated toward go-around thrust, the main landing gear struck the ground 2 meters short of the paved runway surface. And this is where 15 centimeters changed everything. The edge of the runway pavement was raised above the surrounding grass. Soil erosion and years of neglected maintenance had created a sharp concrete step, roughly 6 inches high, right at the boundary between the grass and the pavement. The right main gear slammed directly into that step. The impact exceeded the design limits of the gear assembly. The shock absorber compressed to its maximum stop. The aft end of the bogie was forced upward with such violence that the lower articulation links, the structural connections that allow the bogie to tilt for smooth touchdowns, broke clean in half. The freed bogie swung wildly. Its aft wheels traveled upward past the maximum rotation limit and smashed into the brake hydraulic manifold and the hydraulic lines from both the blue and green systems. The impact also ripped out every electrical harness on the right gear, severing the wires that carried data from all wheel speed sensors, weight on wheels switches, and bogie position indicators. The aircraft bounced back into the air. The crew continued the go-around. They knew they had touched down briefly, but they had no idea what had just happened below them. Below 1,500 feet, all but the most critical warnings are suppressed to avoid distracting pilots during critical phases of flight. So for those first seconds of climb, the cockpit was quiet. Then they passed 1,500 feet, and the warnings started. Landing gear control interface units 1 and 2, fault. Normal brakes, fault. Anti-skid, fault. Thrust reverser. Fault. Message after message, filling the electronic centralized aircraft monitor. The captain asked for ECAM actions. The first officer began reading. The destruction was comprehensive. With the electrical harnesses severed, the landing gear computers could no longer determine whether the right gear was up or down, whether the bogey was in position, whether the wheels were spinning, or whether the aircraft was on the ground. Without wheel speed data, the anti-skid system could not function. Without anti-skid, normal braking was automatically disabled and replaced by alternate braking, which used the blue hydraulic system. Without weight-on-wheels agreement between the left and right gear, the flight computers could not confirm ground contact. And without ground confirmation, the thrust reversers and ground spoilers were locked out, because deploying them in flight could be catastrophic. In the cabin, 162 passengers sat in the turbulence, most unaware that the aircraft beneath them had just lost nearly every system designed to stop it. If you subscribe to this channel, you know that redundancy is the backbone of aviation safety. Every critical system has a backup, sometimes two, but Flight 631 had just experienced something no one had designed for. A single impact had simultaneously destroyed the primary and the backup systems that shared the same physical space on the right main gear. The blue and green hydraulic lines ran through the same area. The electrical harnesses for both landing gear computers were routed together. One event took them all out. But the crew still had options, or so they believed. The alternate brakes ran on the blue hydraulic system, and if those failed, the emergency brakes used stored pressure in the accumulators. 2 more layers of redundancy. The crew worked the problem methodically. They contacted Korean Air Maintenance. They listed every warning. They discussed whether they had touched down on or off the runway without reaching a conclusion. The first officer looked up the abnormal gear procedure and read the steps aloud. Shut down the engine on the affected side after touchdown. Brief the cabin for emergency landing. The captain called the purser, then operations, then air traffic control. Mayday, 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 Korean 631. Landing gear unsafe. Emergency landing. Please prepare. Their actions were professional and thorough, but there was something they could not see, something no checklist covered, something no ECAM message would ever display. The blue hydraulic system had been breached at the right main gear. The broken lines were open to the atmosphere, but the brake dual distribution valve, a device upstream in the system, was keeping the brake lines unpressurized because no one was pressing the pedals. This should have contained the leak, and it did, in one direction. Hydraulic fluid could not flow downstream from the service port through the BDDV to the breach. That path was blocked. But the return line, the path that carries fluid back to the reservoir, was also broken at the gear, and the BDDV was never designed to stop fluid from flowing backward through the return side. Because under normal conditions, fluid in the return line always flows back toward the reservoir. There was no reason for it to go any other direction. Except now there was. The broken return line at the gear had reduced the pressure at that end to atmospheric, and inside the park hydraulic manifold, the damaged pressure release valve was still doing what it had been doing for years, leaking fluid from the service side into the return line at ½ a liter per minute. But now, instead of that fluid flowing up toward the reservoir, it was drawn downward toward the low-pressure breach, through the BDDV, past the broken lines, and out of the aircraft entirely. The blue hydraulic reservoir began to drain. As the crew circled northeast of Cebu, working through ECAM procedures and coordinating with maintenance, the fluid level dropped steadily. They discussed diverting to Davao on the southern island of Mindanao, where the weather was better. But the captain decided they had enough fuel for one more approach at Cebu. That decision, made on reasonable grounds, would turn out to be the luckiest call of the night, because Davao's runway was 1,000 feet shorter, and the additional flying time to get there would have drained the accumulators completely. At 23 local time, as Flight 631 began its 4th approach, the blue reservoir level dropped low enough to trigger another ECAM warning. Hydraulic B reservoir low level. The first officer read the action. Turn off the blue hydraulic pump. The captain acknowledged. The first officer reached up and switched it off. They were following the procedure exactly. The procedure was designed to stop the leak by cutting off the pump that was pushing fluid through the system. And it did stop the pump. but it also cut off the only source replenishing the brake accumulators. Now the accumulators were the last reservoir of braking pressure, and the PRV was still leaking, half a liter per minute, draining the stored pressure that the emergency brakes depended on. By the time the aircraft was descending down the glide slope, most of that pressure was already gone. The A330 was approaching a runway with virtually no brakes. The crew had no way to know this. The captain made a PA to the passengers. Brace for impact. At 23:07 and 39 seconds, Korean Air Flight 631 touched down at the correct speed, within the touchdown zone of runway 22. The touchdown itself was normal. The pilots moved the thrust levers to idle, then back toward reverse. The reversers did not deploy. The spoilers did not extend. The flight computers still believed the aircraft was airborne. The crew pressed the brake pedals hard, because it was all they had left. For 10 seconds, residual accumulator pressure pushed against the wheels. The airspeed fell through 107 knots. The runway was disappearing beneath them. And then, the pedals went soft. The pressure gauge dropped to 0. The last drops of hydraulic fluid that the PRV had not yet stolen were gone. All braking, gone. 173 people on a 200-ton aircraft rolling through the rain at highway speed, with nothing left to stop them. The pilots held the pedals down. Nothing. The first officer reached for the engine master switch to shut down the right engine, per the abnormal gear procedure. Under the extreme stress, he started shutting down the wrong engine. The captain shouted, "Do not shut it off," 7 times. The first officer flipped the switch back. It made no difference either way. The engines were already at idle. Shutting them down would not help deceleration. The end of the runway came through the rainy darkness. Their speed was 83 knots, 152 kilometers per hour. Flight 631 ran off the end of the pavement and onto the overrun area. The nose gear struck a concrete slab supporting the approach lighting system. The slab crumpled, but the aircraft did not stop. It plowed into the localizer antenna and its heavy metal support structure, which was ripped from the ground and hurled over the top of the fuselage. Wrapped in the tangled debris of the antenna, the Airbus A330 finally ground to a halt, 235 meters beyond the runway end, beyond the localizer, meters from the airport boundary, beyond which sat residential buildings and a gas station. There was no fire. The cabin crew began the evacuation immediately through the L2 and R2 doors. The forward L1 and R1 doors could not be opened because the forward fuselage had been badly deformed in the collision. The L3 and R3 doors were blocked by antenna wreckage draped across the fuselage. The L4 and R4 doors were too high off the ground after the nose gear collapsed, tilting the aircraft forward. Partway through the evacuation, a steel bar punctured the R2 slide, taking it out of service. In the end, 173 people, including passengers in wheelchairs who needed special assistance, evacuated through a single remaining exit. The cabin crew went back inside 4 times to verify that no one was left behind. 2 crew members and 15 passengers sustained minor injuries. Everyone survived. The aircraft was destroyed. It remains at Cebu today, stripped of salvageable parts, its Korean Air livery painted over in green, abandoned on a patch of ground beside the runway it could not stop on. As of early 2026, the green paint has begun to peel, revealing the original blue beneath, a 24-year-old airplane that was supposed to retire quietly at the end of 2022. Instead, it sits there, a monument to the night when every layer of redundancy failed at once. The investigation by the Philippine Civil Aviation Authority took more than 2 years. The final report, released in March 2025, identified 3 primary causes. The captain's forward pitch inputs that increased the descent rate during the second approach, the vertical wind conditions, with downdrafts reaching 1,300 feet per minute that compounded the instability, and the 15-centimeter step at the runway edge that turned a hard touchdown into a catastrophic gear failure. But the report went deeper. Investigators reconstructed the hydraulic failure chain link by link. The impact with the runway edge broke the articulation links on the right main gear bogie. The freed bogie swung past its stops and destroyed the brake manifold, the blue and green hydraulic lines, and every electrical harness on the right gear. That single event disabled the weight on wheels sensors, the wheel speed tachometers, the bogey position indicators, the anti-skid, the normal brakes, the thrust reversers, and the ground spoilers. 5 independent safety systems shared the same physical space on the gear assembly. One impact took them all. Then, investigators traced the alternate brake failure. The blue hydraulic lines were broken, but the brake dual distribution valve should have contained the leak. It did, on the service side, but it was never designed to stop fluid from traveling backward through the return line. And the PRV, leaking for years, sent fluid down that path and out through the breach. The BDDV, the hydraulic fuses, the accumulator isolation. Every layer of protection had been designed against a different failure mode. None had been designed for this one. The PRV itself was examined. The damage to its spring was old, its origin unknown. The leak was internal and invisible. It produced no warning. It appeared on no checklist. No routine maintenance procedure for the A330 required checking the PRV's opening pressure. The only symptom was a slightly faster loss of parking brake accumulator pressure after shutdown, something that was expected behavior and never monitored for rate of decay. The report calculated that without the PRV leak, with functional alternate brakes on the left gear alone, the overrun speed would have been 30 knots instead of 83, a slow roll into the grass, a tow truck, a repair bill instead of a hull loss. And then the counterfactual that no one expected. If the crew had diverted to Davao, the additional 30 to 40 minutes of flight time would have bled the accumulators dry through the PRV. Davao's runway was 1,000 feet shorter than Cebu's. The aircraft would have touched down with 0 braking. The overrun speed would have exceeded 100 knots. The aircraft would have left the airport perimeter entirely. Investigators noted that residential structures and commercial buildings lay beyond the Davao runway end. The captain's decision to stay at Cebu, made without knowing any of this, was the single luckiest decision of the entire flight. Korean Air implemented several changes to its training program after the accident, with a particular focus on raw handling skills during turbulent approaches, go-around decision-making at low altitude, and managing complex system failures during critical phases of flight. Airbus began developing new maintenance procedures specifically designed to detect PRV leaks before they could lie dormant long enough to matter, closing the gap that had allowed this fault to hide for years inside the park hydraulic manifold, undetected. The manufacturer also worked on improved thrust reverser logic that would allow deployment even with conflicting weight on wheels data, addressing one of the most consequential lockouts of the night. The authorities at Mactan Cebu International Airport were directed to repair the runway edge, eliminate the 15-centimeter step, and bring threshold conditions up to international standards. Recommendations were also issued to revise the airport's disabled aircraft removal plan, which had proven inadequate for recovering a wide-body aircraft from soft ground beyond the runway end. The pressure release valve that had been leaking undetected for the entire operational life of this aircraft was finally identified, removed, and examined. A small device, a loose spring, half a liter per minute. It had never caused a problem in 24 years of service. It only mattered once. And on that one night in Cebu, it was the difference between an overrun at 30 knots and an overrun at 83. Between a tow truck and a hull loss. Between an incident report and a story that keeps you watching until the end. On October 23, 2022, a Korean Air A330 flew from Seoul to Cebu through a thunderstorm. It carried 173 people. The tech log said no faults. The maintenance records said the aircraft was healthy. Deep inside the park hydraulic manifold, a valve with a broken spring disagreed. It had been disagreeing for years. It leaked half a liter per minute into a line that always carried it home, until one night the line broke, and the fluid had somewhere else to go. If this story kept you watching, consider subscribing. We tell these stories because every one of them makes the next flight safer, and the one after that, and the one you will board next. In our next video, we will take you inside a cockpit where the pilots trusted their instruments, followed every procedure, and still found themselves flying straight toward the ground. Not because the instruments were lying, but because the one person who could have told them the truth chose not to.